Now the laws of surds. Now the laws are the product law, the quotient law, the power law, and the root of root. Now product law is when we multiply two surds, nth root of a into nth root of b, then it will be nth root of ab. If you take the division, nth root of a divided by nth root of b, then nth root of a by b it is. Then power law, nth root of a raised to n is equal to a. Please remember this, nth root of a raised to n is equal to a, because we convert this, it will be a raised to n raised to 1 by n will cancel, it will remain a raised to 1, and that is a. And root of is mth root of nth root of a is mn root of a. So these surd laws are very important calculations of surds, remember that. Now operations on surds. Addition, only like surds can be added and only like surds can be subtracted. This is a very important property, you have to remember that. A nth root of b plus c nth root of b is equal to adding a plus c. Please understand here, it is a nth root of b plus c nth root of b. B and b are the radicands are same. Also I can add, orders are same, so it will be a plus c, coefficients are added, nth root of b. Now for example, 2 root 2 plus 3 root 2 will be 2 plus 3 root of 2, that is 5 root of 2. A times nth root of b minus c times nth root of b, order is same, radicand is same, I can subtract a minus c is equal to nth root of b. For example, 5 root of 2 minus 3 root 2 is 5 minus 3 root 2, and that is 2 root 2. Remember that. Now multiplication of surds. Nth root of a into nth root of b will be nth root of a into b. For example, please understand this, very important, that is cube root of 5 into cube root of 6 is cube root of 5 into 6, and that is cube root of 30. Now here please understand, order of the surds, same orders must be there for multiplication. Order of the surds must be same for multiplication, please remember that. Now a times nth root of b into c times nth root of d is equal to a into c nth root of bd. That means multiply the coefficients a into c and apply this property, that is the nth root of bd. For example, 2 times square root of 5 into 4 times square root of 6, order is same, so 2 into 4 is 8 and square root of 5 into 6 is 30. In order, if orders are different, then you have to make the orders same. In division of surds also, orders have to be same. So nth root of b is equal to nth root of a by b. The root of 6 root by 2 is equal to root of 6 by 2, and that is root 3. And a by a nth root of b c nth root of d is equal to a by c nth root of b by d. For example, 6 root of 6 3 cube root 3 square root of 6 root of 6 3 times square root of 2 will be 6 by 3 into square root of 6 by 2, and that is 2 root 3. So that is how we go for division of surds. Now simplification of surds. If you want to simplify surds, that is 12 times cube root of 192 minus 5 times cube root of 2187 plus 10 times cube root of 648. If you want to simplify this, very simple it is. So 12 times cube root of 192 is 64 into 3. 2187 is 729 into 3. 648 is 216 into 3. Now square root of cube root of 64, as you know, it is 4. Cube root of 3 as it is, and 729 cube root is 9, and cube root of 216 is 6. So now I have 12 into 4 48, cube root of 3, 5 into 9 45, cube root of 3, and 60 cube root of 3. And if you observe very carefully, all these are like surds and with minus and plus sign. So add and subtract here. So I can add 48 and 60 and subtract 45, I get 63 and cube root of 3. So that is how we find out or simplify the surds. Now for division also we have to make the order same. Now divide 6 root of 2 cube root of 4. 6 root of 2 cube root of 4, orders are different here. So 2 raised to 1 by 6, 4 raised to 1 by 3, and convert the or make the denominator same. So if I have to make this as 6, I have to convert into the numerator into 2. So 2 raised to 1 by 6, 4 times 4 raised to 2 by 6, and that will be 6. The 6 root of 2 by 16, and therefore it is 6 root of 1 by 8. Remember that. Now algebraic identities for surds. When we talk about surds, we have some identities as we have in algebra. Root of a plus root of b whole raised to square is equal to a plus b plus 2 times root of ab. Root of a minus root of b whole raised to square is equal to a plus b minus 2 root of ab. That means apply a plus b whole raised to square, a minus b whole raised to square form here. Root of a plus root of b, root of a minus root b is nothing but a plus b into a minus b. Therefore it is root a into root a is a root of a square, that is a, and root b into root b is root of b square, and that is b. Therefore it is a minus b. Root a plus root b into root c plus root d is equal to, applying distributive property, it is root a into c, root a into d, root b into c, and root b into d, applying distributing property. Remember that. Now rationalization. Rationalization is the process of converting a surd into a rational number by multiplying the given surd by another surd known as a rationalizing factor. This is a very important property of surd. If root 2 is a surd, then multiplying by root 2 again, we get root of 4, and that is 2. So here root 2 is a surd and root 2 is another surd, which is the rationalizing factor, because we have got a rational number. So rationalization is the process of converting a surd into a rational number by multiplying by another surd, which is known as the rationalizing factor. If root 2 plus root 3 is a binomial surd, then root 2 minus root 3 is the rationalizing factor, and it is known as the conjugate of the given surd. If root 2 plus root 3 is there, then root 2 minus root 3 is the conjugate of this. If root 2 minus root 3 is there, then root 2 plus root 3 is the conjugate of that. So whenever we want to convert or rationalize any binomial, we have to multiply it by its rationalizing factor, which is its conjugate. Now if root of a plus root of b is a binomial surd, then root a minus root b is a conjugate surd used as rationalizing factor. Root a minus root b is a binomial surd, then root a plus root b is a conjugate, it is also a rationalizing factor. If three surds are there, root a plus root b plus root c is a trinomial, then we have to be careful here. We have to group them, make a pair, that is root a plus root b minus root c, then we have to take the conjugate. So if I pair it, then it will be root a plus root b plus root c, that is this is one group. Then if I change the sign to minus, that becomes the conjugate. You should know how to group it properly. Now rationalizing the denominator, it is a process of removing a radical from the denominator. For example, 3 by root 2. Root 2 is an irrational number in the denominator. Now you have to eliminate it, so therefore I have to rationalize it. To rationalize it, I have to multiply it by root 2, but I cannot multiply only in the denominator, I have to also multiply in the numerator. So therefore remember, rationalizing the denominator, basically it doesn't mean that we only multiply in the denominator, we have to multiply the same number in the numerator also, the rationalizing factor in the numerator also, then only the value of the surd will not change. Remember that. So when I do that, then I have converted root 2 into 2, which is the rational number. So that is what is the rationalizing the denominator. Now rationalize the denominator. You have a binomial here. So the binomial means I have to take the conjugate both in the numerator and the denominator, simplify it, and you find that it is root 2 minus root 3, a plus b minus b is a square minus b square, so 2 minus 3, and that is root 3 minus root 2. So that is what is rationalizing the denominator. Now here we are not only rationalizing, but also we are finding out the unknowns a and b. So let us rationalize this first. 7 plus 3 root 2 multiply by that is conjugate, 7 minus 3 root 2, 7 minus 3 root 2 multiply, then a plus b minus b is a square minus b square, simplify, 7 square is 49, 3 square is 9 into 2, then simplify 49 minus 18, so it will be 7 by 31 minus 3 by 31 root 2. Now compare it with the RHS. So 7 by 31 minus 3 by 31 root 2 is equal to a minus b root 2. So now comparing, a is 7 by 31 and b is 3 by 31. So like that we will be able to solve the examples on surds, whatever the surds are given to us. So learn the fundamentals, the basics of surds is very important, and its application becomes very easy. We will be learning many examples in a separate learning session. Okay. Before that, learn the basics of surds. Thank you.